In this video, I'm going to introduce you to the side-angle-side congruence postulate. The side-angle-side congruence postulate, SAS for short, is the 18th postulate, and it says that if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. Let's illustrate that. Here I have two sides are congruent to two other sides, so side AB is congruent to side XY, and side AC is congruent to side XZ. And the included angle of the two sides is congruent as well. Angle A is congruent to angle X. And since I have those conditions, these two triangles are congruent because of the side-angle-side postulate. Let's utilize this postulate in a proof. So we need to prove that the two triangles are congruent if segment AX is congruent to segment AY and segment AB is an angle bisector of the angle XAY. So we have that AX is congruent to AY, and this AB is an angle bisector. So stating the given will be the first step in our proof, and let's do an informal paragraph proof. So after we write the given, we can say that if you remember by the definition of angle bisector, if a segment is an angle bisector, then it splits the angle into two congruent angles. So that would mean that angle XAB is congruent to angle YAB. So AXB is congruent to YAB. We also know that AB is congruent to itself, and that's by the reflexive property. Now we have that one side is congruent to another side, a second side is congruent to a second side, and the included angle, so the angle between those two sides, is also congruent. So because of our side-angle-side postulate, we can say that the two triangles are congruent. Therefore, by the side-angle-side postulate, triangle AYB is congruent to triangle AXB. And that is what we needed to prove. That given that one segment was congruent to another segment, and one segment was an angle bisector, then those two triangles are congruent. And that is how you use the side-angle-side postulate in a proof.